morning, everyone, and thank you so much for waiting. We are going to start the webinar. Today's webinar will discuss the 7 habits for highly effective DR admins. But before we start the webinar, I wanted to cover a couple of housekeeping items. If you have any questions, there is a questions box in your control panel. Please feel free to type in your questions there. Or if you have any additional comments, you can type it into the chat box as well. So without further ado, I'd like to start the webinar. I'd like to introduce you to Henry Baltazar, a senior analyst at Forrester. He will be covering the topic today. A little bit about Henry. He's a senior analyst serving infrastructure and operations professionals. He has evaluated and tested storage hardware and software offerings for more than 15 years as an industry analyst and as a journalist. Henry advises Forrester clients of data center infrastructure technologies, including storage virtualization, cloud storage, solid-state storage, and primary storage arrays. Henry, you can take it away.
Thanks a lot. Hi, this is Henry Baltazar. Thanks for the introduction, Han. Okay, so in terms of top trends that we've been seeing, it shouldn't be a surprise to many of you, but for many of the enterprises we've talked to, it's typical to see, or for me when I talk to enterprises, it's very typical for us to see 20 to 40% growth rates as being common for many of them, and that equates to about 30% per year, which is how we got to the 60% number that's listed here. I think the big issue with data growth and application growth isn't just this raw number, but the fact that when we talk to customers, most of their budgets are relatively flat, and they don't have the ability, because of flat budgets and this increasing burden of storage, this is becoming a very difficult problem for them to deal with, and it's really forcing them to think differently about how they're going to look at their storage environments going into the future. Another key thing that we're looking at, and another key issue that we see is, while many organizations are trying to move towards 24/7 type operations and the always on, always available type application environments, the big issue that we have is when we talk to customers, only about 26% of them have an RPO of less than an hour, which means for the vast majority of organizations, close to 3/4, it'll take longer than an hour for them to get things back up and running if something happens. And for 48% of organizations, a key issue for them is IT complexity, which is one of their main things that they want to stop. They want to reduce complexity while maintaining their environments going forward. So looking at these a little closer, as we mentioned earlier, data explosion is definitely a key problem that people are trying to deal with, and that's something that's going to be consistent, and it's going to force people to do things differently. Increasing recovery management, we're going to talk about that shortly, but more and more classifying their applications as business critical or mission critical. And because of this, we need to find better ways of protecting these applications and making sure they can come back up online when things happen. Another key issue is, while virtualization has been a great tool for consolidating infrastructure, it does create some complexity, and we're also seeing more heterogeneity with customers moving to add other hypervisor platforms beyond virtualization, beyond VMware, to things like Hyper-V, where we're now seeing 44% of companies using this new platform. Again, two other big challenges that are key for many enterprises is the need to protect mobile users and also limited backup windows, which are forcing people to figure out new ways to protect data beyond tape and figure out ways to accelerate their backups. I think one of the key things when we look at is, there's just so many different ways your organization may be affected by a disaster. So clearly, only about 1% were affected by terrorism, chemical spills, and earthquakes. So while those are mostly unlikely for many of the people in the audience today, 43%, or a fair amount of people a fair amount of organizations suffer because of power failures and other operational failures like that. Also, depending on region, hurricanes may be a big issue, which is what we saw for 12% of our respondents and another 10% for floods. I think the other last key area we want to look at is also human-caused events. Human error is still a very significant aspect in terms of creating downtime, 13% of respondents. And clearly, another thing that's also top of mind and something we'll talk about later is security is going to be a major issue too, whether it be from attacks from outsiders or also from malicious insiders. So in terms of what's the drawbacks and what are the penalties for doing this, the top penalty that customers were talking about were loss of employee productivity due to an outage from their environments. I think the other things that are probably going to come more and more to mind and will become more and more important going forward is the lost business opportunities and lost revenues, especially as you have systems engagements that go down. When those types of outbound facing systems, whether it be your website or any of your client portals or things like that, when those things go down, it definitely damages your corporate reputation, and a lot of these things will add up and have a very detrimental effect on your organization if they're not handled correctly. So step one in this process, we're going to be talking about how you build a clear DR policy to match the needs and requirements for your organization. The two metrics that people look at very closely in terms of how they build their policies out and how they size and gauge the organization are recovery point objective, which is really looking at the amount of data that you're willing to lose in the event of a failure, and also recovery time objective, which is the amount of time it takes to be able to recover after disaster. In a perfect world, in a perfect scenario, you would have RPO and RTOs of 0, in which case you're not losing any data and you're not accruing any downtime when there's some kind of outage or failure. Unfortunately, because of physics and because of the difficulty in moving data across long distances and at times things like that, because of these issues, it's very, very difficult to get or nearly impossible to get RPO 0 and RTO 0 for many environments. But that should be, that's the aspirational goal. More realistic for customers would be to look for RPOs and RTOs, under an hour, closer to a 15-minute range is what we'll see for mid-sized enterprise companies, especially as we start looking at important applications. So when we talk to enterprises and get their feedback on what type of applications they have in the environment, I think it's very interesting that only 29%, they only classify 29% of the applications in their environment as non-critical, which is definitely a key issue for organization. I think that's surprising to me that it's only 29% non-critical. What you should be focusing on is definitely there's so many mission critical and business critical applications and environments that because of that we have to figure out better ways of improving the protection of all environments, since the majority of things are going to be very important. So just want to make sure we understand the distinction here between business critical and mission critical. Mission critical applications are applications where if they go down, your business completely goes down, doesn't function. An example of a mission critical application would be something that I dealt with recently. We're working with a client in a utility company, and they were trying to find out ways of increasing the resiliency of their database systems. With that database system, if that thing went down, your power would go down to a major region of the country. So that's definitely something where it's very clear, very straightforward. That's a mission critical type application. Business critical applications, on the other hand, are things like reporting and some of the other supporting applications that you definitely need to have to optimize your business. You need to have to make sure that things run smoothly and you're not wasting resources. But a lot of these business critical type applications, like some of the supporting analytics and decision-making type tools, if they're down, your company is still able to function. It's just not able to function at optimum rates. So, based on those types of criteria, we looked at what are the different technologies that customers are using to protect these different categories of applications. Yeah, as you can imagine, if people were for mission critical applications and data, they were leaning towards expensive, more proprietary solutions such as synchronous replication at 49%. As you start looking at the business critical and non-critical applications, in that regards, that's when people started looking more towards lower cost means of data protection like asynchronous replication, where it's not there is potential for some data loss, but it can't be minimized based on your ability to optimize WAN links and prioritize data that's being written to the target sites. One of the biggest disruptors that we're seeing for environments today is the cloud, for sure. you know, when we look at what we've been doing for years in terms of how we've been dealing with disaster recovery, while there are cheap or low-cost options such as recovering from tape, from offsite tape, and using cold sites, while those service costs are relatively low, the problem we have there is usually if you're going with that type of format, it could take days potentially for you to recover your data, your applications, and get back up and running, which for many organizations, even smaller ones, that's not really an acceptable outcome. I think on the high end, for the largest of enterprises, the enterprises that have large budgets, a lot of them tend to run technologies such as synchronous replication, which rely on proprietary array technologies and can only be run on short distances, usually within 20, 30 miles between sites. Synchronous replication is great if you have a highly transaction-sensitive type application where you can't lose any transactions at all, but the high costs associated with that make it out of reach for the majority of customers and majority of customer workloads. I think the main thing that we're seeing from key innovations such as virtualization and disaster recovery as a service and cloud backup is we now have a new middle ground gap that's a little more expensive than tape, but should allow customers to get closer to that 1 hour level or a couple hours level of RPO and RTO to help protect workloads that your organization isn't down for days in the event of a disaster. Again, I think this is one of the things we want to highlight. While virtualization has been very, very powerful, I think it's interesting to see that for cloud computing and IIS, improved disaster recovery and business continuity is one of the major drivers. 36% said it was important, and 41% it was very important. Part of why they justified going to cloud. So, while cloud's an enabler, there's definitely a huge appetite for people that want to be able to try to take advantage of cloud to extend disaster recovery. So step 2, we're going to be talking about how you're going to implement and potentially enforce DR testing policies in your environment. A lot of these are basically common sense things that we have to think about, but oftentimes, we're dealing with so many other things, and things like disaster recovery are not always top of mind within your environment. You're thinking about your primary storage, you're thinking about your primary applications, and but it's still important to make sure your infrastructure works well, because at the end of the day, when you have a disaster or something bad happens, you need to rely on something else. So clearly, one of the main things, and basically common sense, but a lot of people don't do it, is after every change, after every upgrade, after every backup, it makes sense to try to make some sort of effort to do DR testing. You may not be able to do it for every one of these incidents, but it definitely makes sense to be able to do more testing throughout the year, because this will ensure that when push comes to shove and when things happen, you'll be able to recover in a timely fashion. Another key thing, if you can't test for every change, every backup, and everything like that, and can't test the entire environment, definitely you should add minimum test servers to make sure that after you do a patch, or maybe even doing the patch on the DR site instead of doing it on the primary site, being able to leverage the architecture in that manner will make sure that at bare minimum, at least you'll have your servers up and running on the other side, even if everything doesn't completely move over seamlessly. I think the other thing to make sure of is the combination of these servers, the combinations of the virtual networking and application integration, all those things have to be tested as well, on a consistent basis to make sure when you do flip the switch, everything goes over and runs smoothly. In terms of testing, right now about 71% are updating their disaster recovery plan about once a year. We believe that customers should be doing more than that, but at this point, only 11% are doing more than twice a year in terms of doing the updates for their DR testing. And clearly, best practice is doing continuous upgrades, but at this point, while this is increasing, only 35% of customers are doing more of a continuous DR plan update. In contrast, there's still about 43% or so that are doing it more in terms of once or twice a year, which is good, but not quite good enough considering the dynamic environments we have today and the high rate of change we have. Both for your applications, your hardware, all the driver changes, all the different updates you have to do to applications. All those things pose a risk in terms of what would happen in the event of a failure. But hopefully we'll be able to see more and more environments move towards continuous testing of their DR infrastructure. Step 3 of this, we're going to be talking about how geography matters and how to leverage cloud and co-location failure sites. So clearly, one of the key things that should be common sense, but if possible, you should try to use multiple sites, to increase to maximize the protection of your environment. You definitely have to make sure that for these sites, they need to be a safe distance apart to avoid the impact of a major disaster. While it's great to have your infrastructure in 2 different buildings, 2 different data centers, if those 2 data centers are very close together and you're impacted by a major maybe it's a weather, inclement weather like a hurricane or something that can affect things on a geographic scale or on a local scale like that. If your sites are in a safe distance apart, you may see an outage anyway. I think the other thing that we're seeing in terms of how to expand it is the customers are more and more looking at cloud and co-location sites to extend the reach of their DR, and also as a means of handling peak workloads without having to make an investment in adding extra resources. Today, for 50% of customers, a lot of them are still insourcing their recovery, whereas for many of the other ones, but I think this will change as things go forward. Most customers aren't looking to build more data center sites, and because of the cost, the expense, and what entails there. But right now, if we're looking at the state of the market today, 58% are still primary insourcing their recovery environments. As we mentioned earlier, the best way to achieve higher availability is to have geographic dispersal and make sure that your data centers are a large distance apart. This example is really more catered towards cloud computing, but it's still, the fundamentals are still the same. If you're trying to look for maximum redundancy and those types of capabilities, it definitely makes more sense to be able to have some geographic distance in between sites. Okay, and as we mentioned earlier, cloud adoption for DR as a service has definitely increased. The last couple of years, we've seen that jump from 4% to 15%, for customers in the past year. With also, a surge in interest for co-location sites as well, which went from 17 to 38%. In terms of average distance between DR sites, for a lot of the customers, based on survey data we've seen from the last couple of years, on average it's been about 600 miles. As you can see, there's still 21% that have less than 25 miles away for their DR sites. While it's good to have that level, while it's good to have redundancy and have employees close to that site, again, the risk there is if something happens that affects an entire city or affects an entire state or entire region, that's not enough coverage for you to have protection in the case of those types of disasters. Okay, step 4, we're going to be talking about how the customers should be looking to warm up recovery sites for the key applications. I think the main thing we're looking at here is, well, it's great to be able to create these policies and create your scenarios for what can happen. You need to make sure you're testing your environment so that when failure happens, it can be done with minimal intervention. If you're working with service providers on the back end, it makes sense to negotiate readiness SLAs with those providers to make sure that the mission critical, your most important workloads have low RPOs and RTOs, based on what fits your budgets. In terms of what's been going on in the last couple of years, we actually in recovery points and recovery times increased in the past couple of years, going from a recovery point of 4.8 hours, approximately 5 hours, to 18 hours. So more and more customers are starting to see it's taking them longer to be able to recover, and in some cases, when they do recover, there is a larger threat for amount of data that they're losing or not being able to recover. Again, this is getting back to the point in terms of working with your service providers, building out your policies. While it's great to be able to have a hot site with RPOs and RTOs of, in the range of under a day or a matter of hours, those type of implementations tend to be expensive and usually reserved for mission critical type workloads. Again, when you look at your workloads, not every workload is going to be hot, not every workload is going to be cold. It really makes sense to take a look at and work with your stakeholders to find out what's really appropriate for them in terms of how long it takes for you to be able to recover these sites again, because there's going to be a huge amount of cost differential associated between hot and cold sites. Going forward, we're definitely telling our customers that it makes sense to be able to look beyond recovery and look towards resiliency. I think for a lot of the old the older deployments, when we didn't have technologies like virtualization, when replication wasn't as easy to attain, they were more focused on just making sure they could recover data. But more and more, again, as we start looking at 24/7 environments and always-on availability, we need to have more proactive resiliency built into the architectures. Next segment we're going to talk about is about networking needs and how to make sure that your network's up to par when you do have a disaster. Definitely, when you're looking at your network, the key things to make sure on both sides are both your primary side and secondary side. You need to make sure your configurations work correctly. You need to make sure that these sites are synced often, and make sure that key services such as DNS will be able to bounce over, because you'll need those in the event of disaster on the secondary side. Connectivity, it definitely makes sense to test the connectivity of your DR failover sites to make sure that the replacement service can communicate on that back end, and also to make sure that they're updating data from your primary site to secondary site in a reasonable fashion. Bandwidth's another key issue. Adequate bandwidth needs to be provisioned at the failover site, because while it'd be great to be able to pull up your site and your resources on the secondary part of the environment, if that side of the environment doesn't have the bandwidth to be able to handle your customer's incoming request, then it'll be just as bad as being down. So definitely, as you're sizing the back-end requirements and sizing what's going to happen after a disaster, you need to make sure that that secondary site can maintain the workload if that's what you need for your SLAs. Another key area we're going to looking about is making sure that you fortify your DR environment. The security at the secondary site needs to be just as strong as the primary infrastructure, so there's no shortcuts there. You have to make sure that if you're doing encryption or whatever type of security you're doing on a primary site, that thing has to be mirrored. That level of security has to be mirrored on your DR site, because you can't really afford to have the secondary site become a vulnerability for an environment. Another key thing is to make sure you're backing up your DR sites, or have, because after you bounce over from a primary to a secondary site, that secondary site is going to become a single point of failure if you don't have backups for this, or if you don't have another way of managing the workload should the second site go down before your primary can recover. Again, one of the key things, the reason why we bring this up is because for many environments, the reason why they're justifying DR, the reason why they can have the budget for this is regulatory or legal drivers are the main things that are pushing people to do this. So, security, compliance, all those different types of aspects, those are not trivial. Those are definitely something that we need to keep in mind as they build out these infrastructures and strategies. Again, I think the other reason is when we talk to people about why they're doing this, it's really about the increased risk, which is why the increased risk of outages and things like that, which is why customers need to improve their DR capabilities. In the final section, we're just going to be talking about how do you expand the value of your DR site. I think one of the main things, one of the main trends that we're seeing in DR as a service, the way I've been talking about this topic with our customers and vendors and things like that is, I think in some ways, I think DR as a service is actually undersold. To me, the way people are selling DR as a service today is kind of like a cheap insurance policy to make sure your resources your applications will be available in the event of disaster. But when you look at the technologies and capabilities of DR service, the ability to, move workloads, the ability to make sure that things are orchestrated in a manner so that complex systems can come back and running in productive state in the event of disaster. Those key functions are really about workload migration. And really in the future, what we're seeing is, to me, DR as a service is not going to be something that you use on your worst day. In the end, it's really going to be a resource that customers are going to want to use every day, because it'll allow them to be able to move workloads to the most appropriate area when they need to do this. With the expansion of cloud and people trying to take advantage of cloud resources and the elasticity of those resources, we're definitely going to see more customers looking to use DR as a service type technologies to build out their hybrid cloud storage strategies. Another good use case for DR, your DR deployment, is to make sure that you can also leverage these resources for test and dev. The good thing about using this as a service is you're not paying for it until you actually activate it. This is actually, you're not paying the bulk of the cost in terms of the virtual machine cost and storage cost and network cost until you actually activate it on the back-end side. But because that's a nice elastic resource, it makes it a good environment for customers to be able to move over workloads, do some test and dev there, do some patch testing, do whatever they need to do on that back end, and when they can confirm the results and get the right outcome, they can shut those down and stop paying for those resources, which is definitely another powerful way you can take advantage of what you build out of your DR site, and make sure it's not just an insurance policy, but actually a good resource that you can leverage, to expand your infrastructure environment going forward. With that, I'm going to hand it over to Quorum.
Thank you so much, Henry, for the information. It's great to understand the best practices around having an effective DR plan. And now I'll have Matt Kern from Quorum show how OnQ covers these best practices.
Thank you so much, An. I'm going to go ahead and share out my screen. And of course, you covered a lot of ground in your presentation. Many, many things for us to think about when we think about crafting our own unique DR plans. I'd like to take a look at the Quorum one-click backup, high availability, and disaster recovery appliance. That's what we're looking at right now, is that dashboard. The Quorum appliance basically automates many of those points brought out during Henry's presentation. Those include RPO, RTO enforcement, the ease of testing, the ability to analyze and automate your networking metrics, and also test and dev. I'm going to take you through each and every one of these. Prior to that, though, to kind of get a flavor of Quorum one-click recovery, I'd like to take you through a failure. The Quorum OnQ appliance keeps clones of your existing virtual or physical Windows or Linux servers within the appliance. These clones are tested. I think one of the keys from Henry's presentation that I hope everyone got was test, test, test. A plan not tested is frankly no plan at all. The Quorum clones, if I mouse over and take a look at the logs, after each update cycle, they are actually tested. During the demonstration here in a couple minutes, I'm going to fail it. Of that server that lives on the appliance, I know it's going to work. It's already been booted today. That's Quorum's concept of assured recovery, automating those mundane tasks. So after each update, these clones have are going to be tested automatically. Let's go ahead and look at an actual failure. This CRM server, it's running up here as a virtual machine, but again, Quorum doesn't care whether it's physical, virtual, Windows, or Linux. We're going to operate exactly the same way I'm going to show you here right now. Here's the actual application. And as I click on a record, request a record, that information is looked up within the database on that server. And the information requested is displayed here on the web page. Pretty simple. Now, let's cause a small disaster. Again, this is the server. I'm going to go ahead and literally pull the plug. I'm just going to power it off. That server is now down. So I'm betting my next query, not much is going to happen. I hope that makes sense to everybody. That query is going down a dead wire now. That server, that business service is no longer available. Eventually, we're going to get this application-specific error message. But rest assured, that server's down. Let's go back to the Quorum on Q dashboard. The first thing I would hope everybody would notice is a big red dot right by the CRM server. So the Quorum appliance is letting me know, hey, that CRM server is now offline. The appliance emails, texts, or both to you and your team, letting you know that that server is no longer available. One of the hallmarks of a good DR plan is simplicity. The run book for this little disaster is pretty simple. Click the red button. That's it. I'm going to do that right now. I'm going to click the red button, and it asks me to confirm. The Quorum appliance is asking me to confirm. Are you sure you want to power on this recovery node onto your production network? Yep. So I'm going to click continue, and what's going to happen now is that clone of the failed server is now going to boot up and take over for the server I failed. Now, if I had a site disaster, I'd have a lot of red dots. Well, you just click on all the red dots. That is a simple run book for a disaster. I can monitor everything from over here on this secondary screen. It's dedicated just to the recovery nodes or clones of your production servers that live on the appliance. You can see that the CRM clone has started, and it's running on the production network. I also have a web console that's available to me to monitor the progress, of the boot. I'm going to go ahead and select that. It's basically just a VNC viewer running on an HTML5 frame. And I can now monitor the boot. You'll notice everything's web-based. So if I happen to be out of the office when the worst does happen, all I need to do is VPN into the Quorum cloud, and you can do everything I'm showing you here with any browser. Now this server, in fact, all the clones on the Quorum appliance are identical clones. And I mean identical in every way. They're going to have the same NetBIOS name. They're going to have the same IP address. They're even going to have the same SID. As this server boots up, we're actually going to see it interact for just a moment with my domain controller, getting any group policies, security policies, etc. In short, at the completion of this boot, this clone of your production system is going to walk, talk, and act exactly like your failed system. Looks like it's up and running. And of course, with my console window here, I can go ahead, log on in, verify everything's okay. But remember, I'd already done an automated self-test. The Quorum appliance is constantly self-testing all of these recovery nodes, so I'm sure it's going to work. Let's get back to our end users. I'm going to go ahead and kick off a refresh here. By the way, step one from Henry's slide deck, build the metrics, RPO and RTO. With Quorum, your RTO is how long does it take your server to boot? That's your RTO. We have full networking within the appliance, and we can get as fancy as you would like with VLAN support, re-IPing of these clones, both locally and remotely. Very, very configurable. And you can see now from our demonstration the power of Quorum's one-click recovery. I'm back up and running. If I return to my dashboard here, you can see everything's all nice and green again, but it's letting me know I'm running on a recovery node that lives on the Quorum appliance. One of the biggest problems with many disaster recovery solutions is you're never quite sure if it works. The testing procedures are arduous, require outage or, at the very least, a performance hit on your production systems. Since the Quorum is 100% fully contained DR within an appliance, everything's all out of band. I'm not using off my SAN. I'm not using processor off my ESX or Hyper-V nodes. I'm just using the Quorum appliance. Additionally, we've got a concept called a test network. The test network is basically 100% disconnected from your production network. It's segmented. So I can actually utilize the test network to do a full DR test. This makes it easy for you to use best practice number 2 from Henry's slide, enforced testing. On my appliance, I've gone ahead and booted up into test mode my critical servers. In this case, a domain controller. It's always nice to have the ability to log on to your network. I've got an Exchange server, a file server, and a SharePoint. Whatever I've defined as my mission or business critical servers. I've booted them up in the middle of the day to do a quick DR test. Now, to power on the test network, I would just select test network. When I had the actual failure, which I demonstrated earlier, I booted up the CRM server on production network. But in this case, I want to show, hey, I want to do a DR test. I'm going to go ahead and power everything on the test network. And that's what I've done with my domain, controller, Exchange, file and print, and SharePoint. I can utilize the same consoles and verify whenever I need to verify, are services running? Are the apps working? Do I have the basic plumbing of DR? And by that, I mean directory services, DHCP, DNS. And I can easily check all those things and verify everything interacting on the test network. In this case, I want to check my Exchange server to see that it's working. You'll notice I logged in automatically utilizing IIS integrated authentication. So that means my Exchange server is talking to my domain controller. Everything talks to itself, so you can get a really good DR test at any time, day or night, utilizing the Quorum OnQ test network. And you can test out any app that you like. Verified document repositories, any application at all. Back to the added value, the dev environment, best practice number 7 from Henry Slides. It's a great place to test software patches, upgrades, etc. 100% out of band. And thereby you remove that risk of applying any software patch for the first time in your production environment. The test network. Always be testing. Finally, the networking analysis. Quorum undergoes a rigorous scoping to ensure that bandwidth, compute power, IOPS, storage, everything's in place for a full DR. However, the monitoring after installation is very, very easy. You'll notice that my DR transfer is all green. In other words, my transfers are occurring at preset limits. If, for example, I were to lose my link, I would see this go to yellow or red here at the desk. Additionally, emails, either text or an email, I should say, will be sent to the proper administrators, letting them know that their memory utilization, their network utilization is out of spec. It's also easy to monitor my backup transfer margins. How long does it take me to do a full backup? And my transfer of those backups to my remote site. This is a very, very high-level overview of the Quorum OnQ appliance. Is there anything else you think I should go over, Han? Henry?
No, I think you covered the basis. We have a few questions if you'd like to go into Q&A. And again, as a friendly reminder, if you do have any questions, please feel free to type it into the questions box.
Sure. I'm ready.
Okay. So one of the questions there is, are these clones encrypted?
By default, the clones are not encrypted. It's an option that we can invoke, however. We get our encryption of these through encrypting drives.
Okay. Next question. If servers exist on multiple VLANs that are protected by the OnQ device, can you accept multiple tagged VLANs at the device itself?
Absolutely. We can do VLANs with different tags, We can also do other tricks like adding NICs to the clones with pre-configured IP addresses or override IP addresses. So those are just a few of a very large bag of tricks that we have to overcome any sort of IP addressing. However, please note that rarely are this my bag of tricks, as I call it, needed, because within the Quorum cloud, once you make that VPN connection into the Quorum cloud, it's going to look like your production network. In other words, the IP addressing scheme is going to be replicated.
Great. And is there a bare metal restore option for easy recovery of the similar hardware?
Absolutely. It's funny you should mention this because I just had to go through this. At Quorum, we eat our own dog food, as you might say, and I had an old Dell 1950. Yeah, I know, it's pretty old. That finally met its maker, and so they came in and they said, "Well, we can't fix it. Here's a 310." So I'd failed over to the Quorum appliance, and I was given basically from the ground up 100% dissimilar hardware. And I used a failback utilizing Quark. That's the OnQ automated recovery kit. It's actually a subset of the same software that's running on our appliances. It actually syncs everything back, but more importantly, it verifies the underlying hardware to what's in the registry and will fix up the registry to match the hardware. It's, in my opinion, the very best BMR tool on the market today.
Great. Another question is this a software application that is able to identify change data for the incrementals along with CPU and memory utilization?
Could you repeat that, please?
Yes. Is this a software application that is able to identify change data for the incrementals along with CPU and memory utilization?
So, yes, we do a very low-level, sub-block level deduplication. For each 8 meg chunk of data on your servers, we're going to subdivide that into 4,000 2K slices, only sending down the new or changed data. So we're not brute forcing, say, a full over your network. That's actually got two big benefits. Back to Henry's point number one, because I'm not moving the same data over the network, I'm just doing these 2K slices that represent the changes, I'm able to back up quickly. Literally in minutes, by hours, or in the case of a couple file servers I used to have, days. Because we can do that, we can back up more often than you could with traditional methodologies. So again, point one, RPO, RTO, we're going to allow you to get a better RPO utilizing this. As far as the utilization of memory, we can monitor the CPU load and memory load and also modify it if needed to provide additional resources to the more critical nodes in your environment.
Great, thank you. Another question is, how do you create test networks that will allow you to replicate the production servers and be able to start up the recovery nodes without conflicting with production nodes?
Well, the servers only live, or excuse me, the network only lives within the appliance. It's not connected to a NIC by default. Now, I can connect it to a NIC, but by default, it's not. So it only lives within the appliance. So if I were to take a look here, you'll notice that I'm not getting out to the internet. Of course, this can be extended into the internet, but this network is not only what we use for the test network, it's what we use for those automated self-tests that ensure the node is going to boot, that ensure your recovery.
It looks like we only have time for about one more question. So, is it possible to do bricklayer restores of Microsoft Exchange mailbox items?
Yes.
Maybe we do have time for one more question. What is the failback procedure to include updated changes to production server?
We're going to use the same tool that I referenced earlier, Quorum, the on-queue automated recovery kit. It's going to take the deduplicated data that's needed from the last backup and update the target machine. Additionally, it will do any sort of registry fix-up. Say that there was some sort of new NIC that was placed in the unit, and now we've got a new NIC. It will actually figure out that, hey, I've got new hardware here. I need to adjust the registry accordingly.
Great. Well, I think that about wraps up our webinar. We've run out of time. Our apologies if we were unable to answer your questions live. We will reach out to you separately to answer any other questions that you may have. And I'd like to take the time